All right, so welcome to week 8, day 1. Today we're essentially going to talk about S3 and DynamoDB. We're going to kind of talk about the difference when to use them, when not to use them. And then we're going to have a lab where you're actually going to host your own front end in an S3. And you're going to be able to like interact with it and see it live. So essentially, Amazon S3 and DynamoDB are foundational AWS services that power virtually every cloud application. So I'm sure by now you know the terms because most people here already passed the certification. So you're familiar with the terms, but today we're going to kind of get more into the reality of what it actually is, opposed to just the like saying, hey, I know the definition, I marked it, the correct answer on the test. Today you are going to build a web app, right? What's going to happen is users are going to upload files, create accounts, track data. Oh, wait. I'm sorry, this isn't the lab portion. This is on me. Let's start over. Welcome to week 8. No, I'm just kidding. So essentially, whenever you're building a web app, users have to interact with it. That's like the whole purpose, especially of the front end, right? So some examples are users can upload files. They can create accounts. They can track data. They can do all this stuff, right? In a world, you can say that, oh, hey, like just we can use our laptop, right? Or we can use like local folders or a hard drive or whatever, but like what happens when you have like so much, you have 10,000 users or 100 million users, it's like, where's all this data going? Are you still like storing it locally? Or you have them maintain it? Essentially what it is, instead of us, the engineers having to worry about like scale, like how do we actually scale this database or whatever, we kind of don't have to, right? And that's the AWS sales pitch right there. Here it says companies like Airbnb and Slack, their engineers essentially just set it up and it's going to, scale automatically. So these, just the two services, the S3 and the DynamoDB, are going to handle 90% of storage. And this is pretty much in the whole universe practically. Let's get started with the S3, the file storage without limits, the S3. S3 does stand for Simple Storage Service. And you can store like anything that you want practically. So any file size, a type, quantity, whatever, it's going to fit in there. It's going to accommodate within there. And the analogy here is unlike your laptop's hard drive, your S3 can handle petabytes of data without managing it on a single day, or excuse me, without you managing it on a single disk. So it's just kind of more of that hands-off approach of when you use these cloud services. Let's kind of talk about a little bit of like what the S3 actually, like what is it, right? So essentially you have a bucket. The bucket's a container. And then each bucket does have its own unique name, right? Meaning, so if someone in Japan has my bucket as a name, you can't use that, it's already off limits. So you can kind of think of buckets as a top level folder that exists across the entire internet. And it's like a top level folder. It's not actually a folder, but just as an example. So within this container, this bucket, you have objects. And the objects are the files that exist inside of the bucket. So you have the bucket that's a container. Within the container, you have objects that are actually files. So then what is this file that we call an object? Well, like, what are the parts of it? So we have a key. That's how we know how to get to that file. So that key is actually just the path or the file name. So here, the example of it, if it's an image, it could be in an image directory. Within the images, we can have a profile directory and then the actual image name, which is user123.jpg. So that whole path is the key that gets you to the object. Then within this file, you have I guess that's a little, within the file, you have the data itself, which is the actual bytes. And then there's metadata. This can be a content type, a custom tag, a timestamp. It's essentially like the attributes of that file, if you would, of the object that is the file. So then you also have a prefix, simulate folders. So this is a flat storage. S3 is a flat storage, so there's no real directories. And this is kind of like when we go back up to the buckets, and where we said, oh, hey, you could think of the bucket as a top-level folder. You could think of it like that, but just know that it's actually a flat storage because there's no real directories. But then here are the keys, which we know is the path to the object, which is in the bucket. And it creates a folder-like structure in the console and CLI. So that's essentially the S3. It is a bucket, which is a container. It has files in it that we call objects. Those files have attributes such as the key, the path, the data, which is the bytes, and the metadata. So that's essentially just the basics of the S3, what makes it up. So then what makes S3 production ready, right? Because it's like, okay, cool, it's a storage system. How is that ready for production? Why am I going to trust it, right? So the first thing is durability. So the S3 does store across multiple facilities. Yeah, you guys already know about the the area zones and the edge locations and such. So here it's designed for 99.9999, a bunch of nines, durability. That's an expected loss rate of zero point then 8 zeros and a 1. You know what I mean? This is the expected loss, which is very, very minimal. So I was kind of curious. I was kind of wondering here. I had added this. I was like, well, what about an actual, just if we had our own hard drive, for example, like a single hard drive, we kept our data on it, what's the reliability of that? So by contrast, the annualized failure rate for a single hard drive or SSD is typically much higher. It's between half to 4% failure rate, which is pretty wild because I know when I think of my own hard drive, I think of it as like, oh, this will last forever. But there is that possibility. I do have a question for you guys. We know that the durability of the S3 is like way higher. Does anyone know why or have guesses as to why?
I mean, other than just the multi-region or just in general?
I'm sorry, I'm not sure if you broke up or got silent.
Just is it because it's can be spread across regions or
Yeah, yeah,
I
that's
guess
that's essentially half of the answer. They're both
okay.
heavily intertwined, but
Yeah.
essentially the difference is that their actual drives are no better, if you would, than other drives, but they have a bunch of them.
It's just split across like a
Yep,
bunch of yeah.
yeah, exactly.
Partition
So
data across, yeah.
yeah, so the idea is that this failure rate here, this is the odds that your data across all of the drives that it's on gets compromised at the same time. And that's why the durability is so high. So then with S3, we also have availability. So S3 serves files 99.99% of the time. That's about 52 minutes of downtime per year. I wonder how that varies, especially this year, but that's usually what it is. And then there's static web hosting that you can use S3 for, and we're going to see this today. So your S3 can actually serve HTML, CSS, and JavaScript directly to browsers, which means that you don't need a server. And once again, we're going to use this in the lab today. So remember that because the S3, it just serves files. So your files can be like JavaScript files, code files, whatever. So then let's talk about DynamoDB a little bit. This is fast data at any scale. So DynamoDB is a NoSQL database, and it's built for speed. So that's important, NoSQL database, that's built for speed. While traditional databases slow down under heavy load, DynamoDB maintains single-digit millisecond response time, whether you have 10 requests or 10 million. So in terms of like if you're using DynamoDB, you don't have to worry about scale. That's kind of what we were saying initially. Like engineers don't have to worry about like, hey, how many users are we going to have? Or what happens if we get a big rush or whatever it may be. Then, so how does DynamoDB actually organize the data? Since it's not SQL, well, it is not SQL, it's not SQL, you have tables that hold your data. So with an SQL database, you don't define columns up front. Wait. Oh, yeah. Unlike SQL database, I was like, that seemed right. Unlike SQL databases, you don't define columns up front. So each item can have different attributes. It's like you don't have to define those attributes. You can kind of just add them as you go. The DynamoDB, in addition to tables, has items. These are individual records. You can think of them like rows in SQL. So each of these items must have a primary key, which we're going to talk about later, but can have any other attribute that you want. So it has to have a primary key, and then the attributes are up to you. You don't have to predefine them. So just the item is essentially that line, if you would, that record within the table. Primary keys is right here. I thought it was way later. So then there's attributes. You should be familiar with attributes in different contexts, but essentially in attributes, are the data fields in each item. So unlike a traditional database, DynamoDB doesn't require a fixed schema. This is kind of what we're talking about. Different items can have different attributes. Once again, you have your table. In your table, you have your items. Your items have attributes. And then those attributes don't have to be initially defined. The only thing that it does need is the primary key. And I seen somebody wave. Is that just coincidence? I assume it was just like rando IRL and not to ask a question. Okay. So then if you remember, you don't need to specify attributes in your item, but you do need a primary key. So the primary key identifies these items, and you have two options. You can have a partition key, or you can have a composite key. So the composite key is actually the partition key plus a sorting key. So let's start with this partition key. The partition key, simply, it's just one attribute that uniquely identifies each item. So here's an example. If you have a user ID, the attribute here can be user underscore 123. So this is now a unique attribute for this, for this user. So then the composite key is the same partition key, which is that unique ID plus a sorting key. So here we have that same user ID, user 123, which is unique. And then we can add the timestamp, for example, which here has this actual time. So this use case in this hypothetical here with the composite key would be that we are going to get like an activity log for this specific user at this specific time. You can also use it for sorting and such, which we're going to get into in a little bit. But so far, I don't think we've said anything crazy, and I think most of you may be familiar with this, but just before we go into like when to use keys and such, so far, are there any questions, or is this essentially mostly what you guys are already familiar with?
That part's so good.
All right, cool. So when to use each key type, because there's the simple, which is just a partition, and the composite, which is a partition plus the sorting. So here, the simple key, when to use each one. It's if you have to do like a user profile, so one per user ID. If you have a product catalog, that whole catalog can have one product ID, for example. Configuration settings, there could be one per setting name. So then what about the composite key? This could be if you need to get an order history, which is many orders per customer. That would be like the customer ID plus like an order history. It could be an ID, it could be a time frame. Then what about chat messages? Many messages per conversation. You can do that as well. If you wanted time series data, once again, those would all require the simple key plus the order, or I guess what do we call it? Plus the sort key, which is a composite key. So then, excuse me, I was about to yawn and cough at the same time. So with S3 versus DynamoDB, how do you choose the right tool? So essentially, like, when do I store stuff in a file, or when do I store stuff in a container versus a proper database? So if you have something like a user profile picture, for example, you can put that in S3, because there's usually, if it's like a large binary file with occasional access. So that'd be kind of the, well, just to clarify, it's not necessarily a profile picture. This is more profile pictures, which would be like not necessarily the main displayed one, but potentially more like the history. Like if you go on Facebook and you can see like your past 20 pictures. But then what about like user profile data, such as records or frequent lookups? Those would be in your actual database. But then, so here's the thing, instead of just reading through this, just to make this clear, essentially, if there's something that's large and is not accessed frequently, it's going to be in your S3. If there's something that's going to be like CRUDed, created, read, updated, deleted, pulled in, just viewed a lot, that's going to be in a database. So that's kind of how you differentiate between the two. It's kind of based off of access. So even just here in these examples for S3, it's like the extra profile pictures. A whole log, for example, like how often is anyone, even engineers, just pulling in logs? It's not super common. Static website files. That's like a website that's absolutely not changing. Like it's just like hard coded. Here's our company information, whatever. That can go in an S3 as well. And then for the actual database, the user profile data, which will get populated probably every time they go to the homepage, every time they log in, whatever. Session tokens, those have to be accessed, even refreshed to ensure that the right user is looking at the right information that would go in the database. And then shopping cart contents. That's because of real-time updates and fast reads. So here it just says the pattern for S3 for files and archives. Oh, the pattern. S3 is for files and archives, and DynamoDB is for application data that needs speed. So everyone's favorite topic, cost management. Don't get surprised, is what it says. So the cloud services, you already know they bill you, right? We're always talking about this. For S3 pricing, what actually costs you money? If you're going to do storage with S3, it's was it just over 2 cents per gigabyte per month for standard storage. So it's really not a lot, but just to make it more digestible, if you were storing 100 gigabytes, it would be $2.30 a month. If you're storing a terabyte, it'd be $23 a month. And in addition to storage, you also have to pay for request. So anytime you're like, put, post, get, right? You're getting something, sending something, reading something, whatever. That all costs money. So a put or a post, it's like if you notice, these are all like less than a penny. So this is like half a penny per 1,000 requests. Even just a little bit less, actually significantly less, is a get request. They don't cost as much as put or post because the put or post is actually updating. The get is just literally just getting it, it's downloading it. Just an example to make this digestible as well. If you uploaded 10,000 files, the cost would be 5 cents. And then downloading them cost, wait, isn't this essentially the same thing? All right, this example is terrible. So just heads up. But these numbers are still accurate here. In addition to storage and request, you do also get charged for data transfers. So if you're putting stuff into the S3 bucket, it's free. Like you can put stuff in it. And this is just strictly with a data transfer, not like an API request. But if you're going to get things out, it's called out to internet. That is the actual term for it. If you're getting things, data transfer out of it, that is going to charge you 9 cents per gigabyte for the first 100 gigabytes. And then this is usually the expensive part for popular websites. Most of your projects, you're really not going to have to worry about most of this. So that should be as encouraging as it is discouraging, because it's like you don't have to worry about the cost, but that's also because no one's really going to use your stuff for a while. But within the company setting, this is good to know. So if you have to advise on which to use and when. So then, of course, since there's money involved, there's also ways to save money. So with the S3 bucket specifically, first thing you can do is use the right storage class. So there's 3 types here, and it's based off of how frequently you're actually accessing that information. Because remember, with S3, it's for stuff that you're really not accessing like all the time. We need this all the time. But even within that, there's like a tier. So the standard, it's frequently accessed files, which is still infrequently compared to the DynamoDB. It's just within its point of reference for itself. So then if it's more, let's say less frequent, then there's infrequent access, which is files accessed less than once per month. This will save you about 50% of the money. Then there's Glacier. Within Glacier, there's also several tiers. I think there's about 5 different tiers. Glacier is what you call more of cold storage. And with this cold storage with Glacier, what it does is it archives, it's for archives that you rarely use. And this is 90% cheaper. And here it does say minutes to retrieve, but it can also take hours depending on the level of Glacier you have. You could save even more money than that 90%, but then it could take literal hours if you wanted to retrieve something out of that database, or excuse me, out of the storage. So then for S3, in addition to using the right storage class, you can set lifecycle policies. So you can automatically move old files to cheaper storage. You can actually have it like where you set it up to where like magically, if you would, it knows like the last time something was actually accessed. And then it can kind of like say, oh yeah, you're not using this and move it to, a different tier. That'll save money. You could set that it's like a time to live well, not a time to live because you're not killing it, but it's essentially a time to live, but with a transfer. And then in addition to the write storage class and setting the life cycles, you can enable S3 intelligent tiering. Lets AWS files move classes automatically. So 2 and 3 are essentially the same, but 3 is managing it, and 2 you're more explicitly configuring it. All right, so that was S3. Once again, that was more for the files with a little less frequent use. For DynamoDB, this is the actual database where you're going to have the frequent stuff utilized. What I'm going to do so no one gets bored, can somebody go ahead and read this portion for DynamoDB pricing?
On on-demand mode, what you'll use in labs. I'm sorry, who's trying to speak to? Paper requests, 125 per million writers, 25 cents per million reads. Great for unpredictable traffic or learning. More expensive per request when provisioned. Provision mode, production at scale, reserve capacity, 0.000065 per write capacity unit per hour. Cheaper for consistent, predictable workloads. Requires capacity planning. Storage 25 cents per gigabyte per month. Same for both modes. I think that was everything that was highlighted, right?
Yep. So that's perfect. I also want to point out if Kathleen can read with while juggling a child, I hope other people can read as well. I hope everyone else can
I
pick.
try.
So yeah, so this is important, right? With DynamoDB, there's that on-demand and provisioned, which is on-demand's pay per request, and then the provisions. Essentially, if you know what your capacity is. For any small projects, there's no way, or new projects, there's no real way to know what your capacity is going to be. So even though reserve capacity can save you money if you actually know what the flow is, it can also be a waste of money because you're now essentially reserving database space that you're not utilizing. So for, I think, every project that we do in this class, it is going to be pay per request, that on demand. And whenever you do a personal project for yourself, I recommend that you use that as well. So just like everything else, there's a way to save money. Can somebody read the cost optimization strategies for DynamoDB?
Just had a quick question on that.
Sure.
So I've used S3 buckets before.
Okay.
I don't remember selecting pay per request. Is that just something that I'm missing in the settings, or is that only DynamoDB? That's only Dynamo.
Yeah, with DynamoDB, it is pay per request. You're asking if S3 has pay per request? No, I think
Yes, or is that
S3 is fixed based off of the frequency,
okay?
based off of the frequency tiers.
Okay. Oh, I guess then default is standard because I don't think I've ever clicked like infrequent access or Glacier.
Oh, for S3, if you haven't, I believe the default is just standard. I believe.
Okay. Interesting. Okay, I'll try and
Because
keep an eye out
especially
next time I
Glacier,
make one.
like I know like Glacier, I think it's like I said, there's like whole other tiers for this. Like so for sure you have to be explicit for this. So yeah, I think the standard is just that default one, and then the other ones you would identify more than likely just by the like the block name, I would assume.
Okay, thank you.
And who was going to volunteer to read DynamoDB cost optimization strategies?
For cost optimization strategy, one, starts with on-demand. Don't over-provision capacities you don't need. Two, use efficient key design. Fewer read equals lower cost. Three, set TTL, time to leave. Automatically delete old items. Four, monitor the CloudWatch. Catch runaway costs early.
Cool, appreciate it. So yeah, exactly. These are going to be some of the cost optimization strategies. So this one we already said, right? Just do the on-demand one, the paper request. You can use efficient designs to like lower API costs, like calls by like caching information on the front end and stuff like that. And then you can also like throttle buttons, and there's a bunch of other cool stuff you can do at least on the front end. And then time to live, exactly. If your company doesn't need to have like old information, just get rid of it. Usually, depending on the company though, Just be careful because some companies do have compliance regulations, right? Like if there's like HIPAA things and we have to keep records for 7 years. So before you go into a company and start deleting stuff, definitely, run that by someone else. And then monitor with CloudWatch. CloudWatch can be your friend, and there's different ways to set that up for just different things. We'll skip the real cost example. Well, no, we'll kind of just look through them real quick. Just to kind of put the database into perspective, if you use 10 gigabytes of S3 plus 1,000 downloads, it would actually be about 30 cents a month. Let's say you had a small app that used S3 and Dynamo with moderate traffic. This is just kind of like a rough guess. It should be about 10 to 20 bucks a month. So essentially, like neither one should really break the bank. But then also if you use other things like Firebase, for example, if you use like GCP Firebase for personal projects, they have like a way larger free tier anyway. So for most of your in fact, I'd say 99.9% of your projects, you'll probably never get charged a penny. But that's personal projects. But then remember, when you're talking about companies that you're working for suggesting things, these numbers are going to be more than relevant. So what you can do is you can set up cost alerts. And here's just a quick little way to do it. But you can literally go to AWS budget in the console, create a budget, set the threshold. So you can start with $10, and then you can also add email notifications. So it's literally you just go into the console and set it. And then here, you'll never be surprised again, Okay. So right now, what you're going to build today's here, but I did add another little section for just some kind of terms and stuff that are good to know. But we'll just go ahead and read this since it's here. Today in the lab, we are going to create a React front end. It is going to be hosted on an S3 as a static website. You are going to use DynamoDB table, which is going to store the application data. And then you are going to direct SDK integration from the browser to DynamoDB. And then you're actually going to visit your site like live in the browser. You can also interact with it, add data, etc. And then for now, it won't let me go to the next thing because of the UI. So let's go here.
Hey, Jonathan, I have a question. The time to live for DynamoDB.
Okay.
Say you're in an organization that has to hold on to old data for archival compliance reasons.
Mm-hmm.
You would then transfer that to like an S3 Glacier type service, right?
Yep.
So would you say you had like after 2 years, for example, right? I want to store it for another 20 years. Would you use what would you use to kind of automatically trigger that? Would it be more like a Lambda function to okay, after it hits 2 years plus 1 second, it transfers that over to S3 Glacier? Is that a right method?
So that's a good question. I don't have the exact answer for you. What I can tell you for sure, and I know that's not what you want to hear, but for sure, your logic is correct. You do specify the time periods and you can have that automated. I know there's two ways to do it because you can do it through AWS, just in the config and have it do it. But then there's another way where you can hybrid manually config it. But your conditional example that you gave is how it works. That's exactly how it works. So because even within those Glacier, like I said, there's 5 different Glacier tiers. So you could even set it up to say, hey, we start out in standard storage and then move it down to Glacier, or move it straight to Glacier, whatever it is. But yeah, if you're hoping for the exact, hey, here's the exact steps, I don't currently have that. But I can also look that up while you guys are doing your project because now I am curious.
Okay, thanks.
Cool, great question. Was there any other questions before we go into the configs? Okay. Here's the thing with the configs. I'll be honest, I'm not sure if you guys had already learned this last week or not. So if there's something that you think has been beat to death or it's not beneficial, just go ahead, raise your hand, let me know, and we can skip this. Because for sure you guys know this, right? The basic bucket creation. You already know, here you have the resource, the name, the label. I know you guys know this. Have you guys used bucket versioning yet? I see a thumbs up. No?
I don't think so.
Okay.
Mm-mm.
So if you guys remember, on that first day when I had mentioned Terraform and stuff, I was like, hey guys, it keeps track of your versions. So it does. But the thing here is you have to enable it. So that's versioning. It's there, but here you go. You can actually enable it. So versioning underscore configuration status equals enabled. Then there's public access settings. So whenever you're creating an S3 bucket, it's already private. That's like part of that's just part of like, the benefit that you get is like a lot of the security is already enabled. But then what happens if you don't want like, that level of security? So here what you would do is you have the public access block, right? You already know the name doesn't matter. The bucket references itself. I think you guys have already used this line several times, correct? Like you must have. If not, you'll see that more in the lab. So then here, though, this is the actual security. Like we're literally taking like the policies and we're taking like the acts and we're saying, hey, false. We don't like we don't want these. So if you don't specify, they're all true. In a real life setting, I'm not necessarily sure that you would do this, but what I will say is for small personal projects, for labs that we create, you are going to do this because it's just going to prevent any like other additional conflicts and troubleshooting. Just to know that it's like, hey, it's open, there's no security, and it's just going to take away a lot of the heartache. And then I think later on in the course, then we deal with the heartache a little bit more. So what's the security note? Only make buckets public when absolutely necessary, like static websites. Most buckets should remain private. Okay, yeah, I guess that makes sense too if it's a static website. Okay, so solid security note. So Terraform configuration. Let's see, I know some of these are. So you guys just learned about a partition key. Do you guys remember what that is?
It's a
It's where you
unique
have the
identifier.
Say again?
was
Y-
but
Go ahead, Kathleen.
yeah, so it's basically the name of the resource. There's the I was thinking of the other key though. I'm sorry. I was thinking the split key. It's like the username and then the time. Sorry.
Oh yeah, yeah, okay. Like the composite key is what you're referring to. So
Yeah,
with the
that's what I
partition
was thinking.
key,
Yeah.
the partition key is going to be right here. So
Okay,
it's the
hash key.
hash key, and then it's that unique name. So like if it's a user, we're going to address them by the user ID. So that is the partition key. So, but not only do we have this key, we have an attribute, and the attribute is essentially it's like a type check. So in this instance, the user ID is a string. If you guys have already, I'm not sure if you already know about types, but a string is essentially numbers and letters that are not like mathematically calculated. So for example, my name is a string. If say my user name is John, my user ID, my user ID, let's say it's like Jonathan 13. That 13 is a string because there's no mathematical like component to those numbers. So it could be a string, it could be a number, etc. We're gonna actually look at some of those later. But yeah, this is essentially it. This is the whole partition key, and then this is the attribute. So you name it again, and then you give it a type. But then with the composite key, do you guys remember what that is?
So when I was talking about add, both the other key, I'm spacing right now. Sorry, the not a private key, primary key, but the other key, and then some additional attribute that defines that, like a timestamp.
Yeah.
So just
So
two
so
keys. Yeah.
so yeah, no, that's correct. So exactly. So it's two keys, which is the primary key, and then it's going to be used with some sort of like sorting key or like a range key, just something to like filter. You can kind of think of it as a filter key as well if you'd like. So in this example with the composite key, right, we know that it's the regular primary key or partition key, excuse me, I knew that was wrong. The partition key. So you can see it right here. The hash key is customer ID. And then here's the attribute specifically for that hash key, for the partition key. So it's the same name and it's going to be a string. But then also remember, the composite key is two keys. The other one, in our case, is a range key. And this is the order date in our example. So we're naming it order date. And then the range key, its attribute is defined right here, where it has a name, which is the same name, and then it has a type that's a string. So essentially in this example, what it's going to do is it's going to pull up all the orders for one user based on the specific date. Does that make sense? And this is just the config. We're going to go more into like how it's working. But so far, does this portion make sense? Or does it not make sense to anyone? All right. So some DynamoDB Terraform notes. You guys already know about this. There's two billing modes. There's a pay per request. That's the one that we're going to use. That's just like the pay-as-you-go method. Then there's provisioned. Once again, that's where you're reserving a capacity in advance. That's where if you know how many users or how much usage you're going to have, you can actually prepay for a certain amount. But if you don't use it, it is what it is. You still got to pay the bill for it because you reserved it. Here are some attribute types. I wonder why this is here. It seems a little out of place. But not the attribute types, the billing modes. But for these attribute types, so in this first column, I forgot we can't do that. In this first column, these are just example names. They can be anything that you name them. But just for an example, if we had an attribute name called user ID, it would be a string. And then here's an example of a string. And here we're defining it as standard text data. Some other examples, instead of a string, we can do a number, which would literally be numbers. And notice there's no quotes around it. That means this is like a mathematical number. You could put bool, B-O-O-L, which is a Boolean. That's like true or false. This is stores logical true or false. Oh, okay. These descriptions aren't that much help. They're pretty self-explanatory. So then we have SS, which is a string set. And then here it's an object with it should have more than one string within it, or a collection of unique strings. There's B, that's binary. This one gets pretty wild. I was looking it up, and it doesn't exist too much. It's not, but essentially what you do is like you actually have to like go through and like hash it and stuff. You know, you have to put in like a hash, like this secret encrypted like binary version. So it's not used in this use case too much. There's also NS, which is a number set. It's very similar to the string set. It's an object, but instead of with unique strings, it's an object with unique numbers. And notice there's no quotes around those numbers. There's also M for map, which is key value pairs. So here we would have a theme that's dark, and we'd have a size that's 12. The keys are always going to be in quotes, and the values can be in quotes if they're a string, if they're a string, excuse me, or they can be without quotes if they're actually a number. And then L is a list. This is an array. So it's kind of like an object, but it's not, sort of. And then just for context, just to go back, this S, the N, the Boolean, whatever, you're going to use it right here. So whenever you have your key, if it's primary or composite, you're going to go ahead and create your attribute and then put the type here, whether it's a string, a Boolean, a number, whatever. So some of the other terms that you do need to know, there's schema flexibility, which is you only define attributes used in the keys. DynamoDB items have any other attributes without declaring them in Terraform. Or excuse me, it's just they don't have. Oh, can have, yeah. Oh, okay, yeah, it's saying what we said before. So essentially, normally when you're working with a backend, especially like an SQL backend, but even with no SQL backend as well, you create a schema, which is like you create an object. Let's say it's a user. Your user has attributes. They could be whatever you want, whatever's relevant to the app. So it can be like first name, last name, age, address, whatever, right? Those are all the attributes. And essentially what it's saying here is that instead of predefining that in your schema, you can just add them as you need them. So this is kind of like schema flexibility. It's you only define attributes used in keys, and you only use what you actually need. It's not like a, oh, we might sort of deal. There's something called key point, which is you only define attributes used in keys, which could be partition keys and sort keys. And DynamoDB items can have any other attributes without declaring them in Terraform. Okay, I mean, this is essentially this. Oh, yeah, it's just reiterating what schema flexibility is. So what this means, it means DynamoDB is schemaless for non-key attributes. It also means that different items in the same table can have complexity different attributes, or completely, excuse me, I'm getting old. So I'll just read that again. Different items in the same table can have completely different attributes. And then also, You only declare key attributes in your Terraform config because DynamoDB needs them for indexing. So those attributes are important. They are utilized for indexing. And then here's just another example. Let's see if this is relevant. So here we're creating a table, right? The resource is the AWS DynamoDB table. We're choosing to name this one user. So it's going to be a user table. This would have a name that we're calling users. It's going to have a billing mode that we're specifying as pay per request. And then it's going to have a hash key. It says must declare this. This is the the same key, the partition key that we've been talking about right here. So since we have the one key defined, we have the one attribute for it. So here's the same partition key. It's a string. And then here's just a comment, which is going to reiterate. You don't need to declare other attributes like email, name, age, preference, etc. Items can have any attributes you want. So essentially, just to clarify, you're only defining an attribute for the key. All of the other attributes that you would normally define for a user, you don't have to. It's just going to accept what you give it. So yeah, this is just an overview of the configs, and we're about to get into the lab. Does anyone have any questions about any of this? All right, let's get cracking on this lab. So what the lab, if you'd like to follow along, actually, okay, I'll say this. If I remember, I think the challenge expands on the lab. So if you do follow along, just make sure to update, have a unique S3, because if not, we're just going to run into those conflicts. And all right, so yeah, that's essentially the disclaimer. So today for the lab, what we're going to be building, we're building a task manager app. It's going to allow users to create a task. You can mark the task as complete, and you can delete them. So these are the three main functions for the user. We're going to create it in React, and the front end is going to be on S3. And the data, right, all these tasks are actually going to be within DynamoDB. So by the end, you're going to visit a real URL. You're going to see this task app deployed. We call it like in prod, it's going to be deployed. And you can interact with it. So you can do all of this stuff mentioned up here, and it's actually going to trigger the database. So you could refresh it, whatever you want to do, it's going to persist because it's coming from the database. So some of the objectives. By completing this lab, you are going to create a DynamoDB table with Terraform. You're going to create an S3 bucket configured for static website hosting. You're going to deploy a React. I don't know why I'm so tired today. We're going to deploy a React application to S3. We're going to connect the front end to DynamoDB using AWS SDK. And we're going to verify that the full stack works. Here it says it takes about 90 minutes. It won't take that long because everything is done. With the labs, we're kind of just going to talk about it, follow along. Some of the prerequisites that you do need if you're going to follow along, or if you're going to do just kind of like run through it later before your challenge. You do have to have AWS CLI, which you just run this command. Everyone should already have this set up. And then have Node 18 plus, so 18 or newer. And then you have to have Terraform installed, and you can check the version to ensure that it's there. So what I'm going to do now is hop over to here. We'll kind of get cracking. The first thing we're going to do here is we're creating this main folder. I already created it. But yeah, we're going to create that. Within this folder, we're going to create two more tables with the make directory command. So if you're not familiar, mkdir, make directory, it's just going to create folders. So here we have one called Terraform and front end. If you look here on the left side in this file view, you're going to see them populate when I hit enter. So right now we have two empty folders that we had just defined. That's the first step. There's another cool thing here. If you guys are familiar with the touch command, the same way mkdir, which is make directory, makes folders, touch actually makes files. So what I'm doing here is defining the path of where I want it. So I want to make a file called main.tf, but it's going to be within the Terraform folder. So now if we check Terraform, we can see main.tf on the left side. And just quick yes or no. Are you guys already familiar with these commands and using the Visual Explorer in VS Code?
Yes.
Okay.
Yes.
So I'll speed it up a bit then. Well, actually, I guess we're done with that portion, but we could have skipped that. All right. So essentially, now what we're going to do isn't going to blow your mind. You're going to notice that this is exactly what we've done every time so far. And main.tf, we're going to start out with Terraform. Here's a required version. For the provider, we're specifying that it's AWS. And then here we have the random that's going to be utilized more later. But essentially, the source is HashiCorp. The provider's AWS, the region's US East 1. You've done this on every project, so we'll skip past this explanation. So then what we are going to add is this right here, which you haven't utilized yet. I don't believe you have. So here the resource, you've seen this in the example. It's AWS DynamoDB table. This is how we are actually utilizing a DynamoDB table. We're choosing to name it task. That could be anything we want, but it's relevant to our task project. Here the name is Task Manager Tasks, plural. Whenever you're working with a database, it is advisable that you use plurals, since you're going to have more than one, one item within it. The billing mode. I know Kathleen had asked before, hey, I never specified billing mode. So with S3, correct. And then with DynamoDB, you do have to specify it. So here we're doing the pay per request. And then we're setting a partition key. In our use case for these tasks, we're just calling them ID. We could also call them task ID, whatever. But just to follow along with the lab, we're going to keep them as ID. And then do you guys remember when you have a partition key, what you have to do? Any guesses on what you have to do? What is required with the partition key?
Yeah, the attribute, the type.
Yep, correct. And here we're specifying the type as a string. And here you can even notice the ID is literally a string. It's in quotes. It's literally a string. And then we're going to add a tag for the project, which is going to be Task Manager. So what we're going to do now is we're going to add some of the IAM policies. Have you guys already set up these IAM policies before? Or is this brand new to you? Starting here at line 34. All right, it sounds like you haven't seen them. So with the IAM policies, they're essentially related to user roles. It's kind of like access that that you can have. So for here, we're declaring or calling in the AWS IAM user. We're choosing to name it front-end user. And then here we're just naming it Task Manager front end again. This is similar. Oh, that's not the same. So yeah, Task Manager front end. And then here, now we're using AWS IAM access key. So we're going to name it front end key. And then here, the user we're defining, you'll notice that we're pulling in from the resource we've already declared above, right? So right here on line 39, we're utilizing this resource. And then specifically, we're now using the front end user. Once again, the resource we did, and the name. So I think you guys have already utilized this. Whenever you have like some sort of an object, what you can do is like you can dig in deeper. Usually when you get a payload from the back end, you can get an object and kind of dig through it. And that's what we're doing here. So here it's just, once again, whenever you see these dots in between, it means that front end user is part of, part of this. And then the name is part of that. So you're kind of digging into it, which is all, it's just what we defined here. But now we're defining it as the key. So within this next code block, we now have the AWS IAM user policy. So because we already have the key established, now we're going to talk about the policy. And this one specifically, front-end DynamoDB. So you could name it whatever you want. We're choosing to name it DynamoDB access. And the user, you're going to notice similar. Remember how here we kind of dug through this resource we created? We're doing the same thing. So AWS IAM user, the front-end user, which we've established up top, and then the name. We're getting the same exact user variable here. So, once you create it, it's global. And if you remember, whatever you custom name is how you refer within. All right, cool. So within this user policy, here's the actual policy. And then for this, I do have an explanation for you that I wrote down. Because within this policy, we have a few things happening, right? We have this function. Have you guys already used this JSON encode? Because I would assume you have not.
No.
Okay. Let me pull this up here so you could read along with me. Let's find this bad boy right here. Okay. So JSON encode function. It's a function, it's a Terraform built-in function. So it just comes out the box. And it's used to convert complex Terraform data structures, like a map or a list, into a single line JSON format. So JSON encode, it's literally restructuring it into a readable single line JSON. What's the purpose? With AWS S3 bucket policies, they must be defined as a single valid JSON string. So this isn't optional because your data is never going to come back or be formatted as a string. So we need to do that so it's compatible. And then Terraform's HCL, it's designed to be readable, but it needs a way to guarantee the policy is serialized correctly before it's sent to AWS. So this is essentially saying like you have to do it because the bucket's not going to do it for you. So let me see if this is worth. Okay. So yeah, so here it's just saying like this is readable. And then here it's saying that this is like how it's actually required to look. So if you notice here, like the version and statement, these, I guess they're not keys, but this version and statement, it's not a string. This is like a declared variable saying version equals this. But then according to the S3 bucket, it's going to say, I don't know what the hell you're talking about. So instead, we're creating a JSON object that's a key value pair where the keys are strings and the values are whatever they need to be. So that's what the JSON encode is doing. It's just converting what it gets into this. So then from here, then we have the statement. And within the statement, we have the effect, we have the action, we have the resources. And then for this, I wrote down this explanation for you guys as well. So the statement block defines permissions for interacting with the DynamoDB table. And that's literally just this whole thing here, just this whole little block. So within that, you have effect. What is it? It determines whether the policy allows or denies access. Possible values. You can only do allow or deny. If you allow, you grant access to the specified actions and resources, which are going to come next. If you deny it, you're preventing access. So here, we're allowing it. So then, like we said, what are we allowing? We're allowing the actions and resources. So what are the actions? The actions are specific AWS API operations that are being allowed or denied. In our specific example, we have put item, get item, delete item, scan, and update item. And those are exactly what they sound like. Like you're either getting it, putting it, deleting it, reading it, or updating it. And within here, these actions, since we're specifying it, we already said, yes, these are allowed. So, our user can do all of those actions without security, without security stopping it. But we're also allowing resources. AWS resource or set of resources, the policy statement applies to. Wait, what is that? Am I getting old? The AWS resource or set of resources the policy statement applies to. So in our example, we're using the table, task, and then ARN. So here AWS, DynamoDB, table task ARN, what we're specifying. It is the unique ARN of the DynamoDB table named task. Unlike S3 policies, there's no / suffix because DynamoDB permissions apply to the table itself, not individual items within it. So essentially here, it's just kind of saying like, yeah, this is cool. Like, yeah, we'll allow this specific table to like run amok if you would. Not run amok, but do all of the actions. So essentially, just to clarify, this is part of the IAM, it's just part of security of limiting what can or can't be done. So that's essentially, oh no, we still have some more resources to put in here. Okay. So aside from just that black and white like security stuff, we have to start setting up our config for the website itself, opposed to just the interactions with it. So here, at the moment, this isn't necessarily being used, but we're defining, or we're getting a random string, and we're calling that the bucket suffix. We're going to use this to create the bucket name. This random string is going to have 8 characters exactly. It's going to be lowercase, which is true, uppercase is false, so it's all lowercase, and it won't have any special characters. And then what we can do is here. For the AWS, for the S3 bucket itself, we're going to call this one website. And then why? Because it's like literally where our website's going to be hosted. So here we're going to name it. We're going to name it Task Manager, but then we're actually pulling in what we just defined before. So random string, the bucket suffix, and the results, which is the whole result of this. So that means we're now dynamically naming our bucket with a random name. And this is so we don't have repeat bucket names. And this is good, especially here since we're all following along with each other. But then now with the S3, so it's like, okay, cool, we have the bucket, we have the S3 bucket for the site, but that's not quite enough, right? So here specifically, because AWS has a resource for everything, they specifically have one for the S3 bucket with the website configuration. So we're calling this website. Here, the bucket, it's AWS S3 bucket, so we're referring back to the previous resource, .website.id. So essentially when this is done, we're going to collect the ID, and that's what this version of the bucket's called. And then index document, this is like the home page. Here it's utilizing index.html. Whenever you're using like React, Vite, whatever, like React or Angular, all of your magic is actually happening in like a JS file, but it has to be read by the DOM. So the public facing is always going to be index.html, which is going to kind of be like, how it's going to essentially like middleware into your actual components. But then here there's an error document. And then here you'll notice for our example, the key is exactly the same. So an example for an error document could be like a 404. Like if someone's trying to go to like, ourwebsite.com/whatever, and it no longer exists, instead of, we could define a 404, but here we're just going to send them back to the home page. All right, let's see what else we got here. Okay, so we're still not done with this config. So let me just stop so we could take a breath. I know all of this is new, but all of this is essentially, well, not essentially, it's the same pattern that you guys have already been working with. The only difference now is it's just like different variables in a sense. But so far, does this portion make sense?
Is it typical that you'd have like the error document be the same as the index document?
I'm sorry, the first part of your question broke up. Could you repeat it?
I'm just thinking, is like the error document and the index document, is the error document, maybe you already said, but is that just like when you get like a 404 error, that's what one shows?
So you are correct. I did say it, and you are correct. That's exactly what it is. So it's a redirect in a case of an error, with an example being a 404. In our use case, we're just redirecting to the home page, but we could specify this as a separate page. That would be a proper 404.
Okay, thank you.
All right, so let's see what we got here. Okay, so even though we have the those permissions set up, like, oh yeah, the user can post this, whatever. Okay, that's like the user, through the IAM role, but it's still not like assessed publicly. Actually, didn't we define this? Or did I just show the example? Oh, okay, yeah. So I had showed the example of this earlier in the lesson. But remember, by default, AWS is very secure, which is good. That's what you're paying for. But in our case, we want the public access to be public. Normally, you would specify this. But in our case, what we're going to do is pull this in once again as for our website. And then we're just going to take these chunks here and put them to all false, which means that essentially our website is going to have no real security, and anyone with like a postman or the URL can just ping it and just start utilizing it. Like, I guess technically if they wanted, they could make their own front end as well, just like whatever they wanted. All right, so then we also need to have a policy for it to be read, because it says access right here. It's literally just that. It's just to access it. But just because you can access something doesn't mean you have permissions to read, to actually read it. So this next one should be for that. So here it's just the bucket policy, so not the access block, but the actual bucket policy. You'll notice the same convention, we're naming it website. You'll notice that all of these bucket names are exactly the same, right? Because it's the same bucket. And then the policy, we know JSON encode does what? Does anybody know or remember?
Translates like Terraform into JSON single string or single line so that S3 AWS can actually read it for the S3.
Correct. So it's pretty much getting the response, the HCL. And then what it's doing is it's saying, hey, ACL, I'm going to reformat you into JSON. So S3 can actually understand what you are. So yeah, perfect answer. So with this, we're establishing the version based off of the date. Or here it's an arbitrary date. Actually, I'm sorry, that's the actual version. Sorry about that. Okay, and then the statement's essentially the same thing, right? You guys remember what the statement's for? No? All right, it's all right. Here, we have that whole thing written out for clarity, if we can find it. Oh, right here. So can someone read that? What does the statement do? Or what is the statement for?
The statement block defines permissions for interacting with DynamoDB table.
Correct. So whenever we're dealing with permissions here, with like in this policy, we need this statement block because that's going to define like what's actually allowed to interact with it. And then before we had those instances, here we have slightly different ones. Let me see if I have this other block here, which I think I included. Actually, which step are we on? Step 4.5. Oh, wow, I'm way past that. Oh, right here. It's really hard to find. Okay, so the only thing, so now within this statement block, right, what's allowed to interact with it, we have slightly different attributes from before. So here we have an SID, which is a statement ID. It's a unique optional identifier. We didn't use it before, right? It's optional identifier for the statement within the policy. It helps with readability, auditing, debugging. AWS tools sometimes reference the SID when logging access attempts. So here, the values that we use was public read get object, and it's a descriptive name for the specific rule. So right here, that's the ID for it, the statement ID. And then we already know the effects we can allow or deny. In our case, we're going to allow it. Here, what you did not see earlier is principal. Principal is the entity. So that could be a user, a role, a service, or an account. It's the entity that is being granted or denied access, defined in the statement. So possible things you can add that we're not using. You can do a specific ARN, such as this. You can also do a specific AWS service, such as saying, hey, yeah, let just only S3 can access it. In our case, we're using an asterisk. Whenever you see an asterisk, know that it means all, essentially what it means. It's like every, all. So if you're setting up like a CORS policy or something on a back end, and you see the asterisk, that means anyone, anyone and their mama or whatever can access. So that's what we're doing here. We're just saying like anyone can access it. Any service can access it. That's fine. Then there's action. This is AWS API operation or set of operations that's being allowed or denied. The purpose of the action is for S3. These typically start with S3, ... So in our case, it's S3, get object. This permission is needed to read or download an object because of the get. This is if you were doing like an API call, you have get, put, post, delete, usually. And in our case, get is literally to get it. So here, the action for this, we're saying, hey, let's get the object. And then the resource or set of resources is that the policy statement applies to. So here we have a specific value, which is right, the bucket, the website, and then the ARN. So where are we at here? So here the ARN it's a unique ARN of the S3 bucket itself. So this isn't something we're making up. This is the specific for the bucket. And then here, if you have this suffix, do you guys have an idea what this one could mean? Forward slash and an asterisk?
I mean, that's kind of like a path with a wild card after it. So it could be like any path after that.
Correct. Yeah, wildcard is what it's called. So yeah, the asterisk just kind of means like all. So in our case, it's saying, hey, this and anything, kind of like I said, we're kind of diving a little deeper here, right? Anything within there, it's like fair game, like we're cool. So here the depends on, I don't think we have an explanation for depends on, but essentially what the depends on is just that. So here it depends on, if we look here, we got this resource that we made earlier, which means that this new resource, this bucket policy, it cannot run until this specific resource is done. It depends on it to run. And the reason why is like, if not, you can have it like kind of like out of sync where like sometimes things need other things to be done first, or sometimes things need to get information from other things that are still calling it. You're going to kind of see an example of this concept. We're going to use some async functions, async await, but essentially it's just that. So just once again, this is dependent on this finishing first, then this will run. Oh, there's a thing here that says about depends. It says ensures the public access block is configured before the policy applies. I mean, that's what I said, but that's, just here saying this thing. It's waiting for that thing. All right. And then let's see what else we got here. Add outputs. Okay. Is it to the same policy? Yeah. All right. So here's what we're going to do now. We're in the same main.tf still. Yeah, all right. And say main.tf, we're going to add some outputs. And then you guys remember that outputs, essentially when we run it, it's what we're going to see in our terminal. So one of the outputs that we want to see is the website URL. So here's the description, and then here's the value. This is actually going to pull in the URL from the config. We also want to see our bucket name. Once again, it's going to pull in the bucket name from AWS. DynamoDB table. We actually want to see the table and the values. And then here the access key ID, and then the secret access key ID. We're going to have to input some of these manually, which actually, do I still have? I will find out right now. So yeah, you guys are already familiar with how output works, and then just here's just these specific values. And then the one thing it does say though, with this key here, sensitive equals true. In this case, with me screen sharing and recording, obviously there's no such thing as actual sensitive, right? I'm going to go through after and delete the key that I'm using here. But here, what it does is it hides the secret in the logs, but it still lets you retrieve it. So if you don't do this, like say we did false, that means anyone in the log can literally just see it. And yeah, so essentially it's just you're giving away your secret key. People can use it, and then they can just run up your bill on their own apps or whatever. All right. So right now we have this infrastructure set up. So what we're going to do is we're going to go into our actual Terraform folder. Do you guys know what we're going to do now? Which commands we're going to run? We just
Terraform init.
Correct. Did I hear different answers, or did everyone say the same one?
No, we said
I
the
think
same.
we said the same thing. Yeah.
Yeah.
Okay, perfect. So exactly, with Terraform, you're always going to init, and then you're going to apply. I'm throwing both of these in. They should both run sequentially. And then you see here, all right. So we know that everything's working because we can already see the files that it needs loading in. And then do we want to check changes to outputs? Oh yeah, see everything here, it doesn't even know it yet because it can't pull something that doesn't exist or that it doesn't even have access to. Okay. So we'll give this a second to get rocking. All right, cool. So now we can see in the output, now there's actually a key ID. There's actually a secret key. Oh, it's sensitive. Of course it is. That's what we wanted. It has the bucket name, has the table name, and then it has the website URL, which of course there's nothing there, so it doesn't really matter. We'll play with that later. Then there's this that I mean, it didn't work for me earlier, but let's see if it works now. Right here. Cool. So here what we did is we got the output, the Terraform output. We specifically wanted in JSON format, and then we wanted it in this outputs.json. So here we can see everything, including the sensitive key. Because if you remember, with the secret key, it's sensitive, which means it's sensitive, it's hidden, if you would, or more of like, it's kind of like, I don't know the right word because it's not encoded. It's not necessarily hashed, but it's scrambled, if you would. I think it may be a little more accurate. And that's why in the output, we couldn't see it. But now that we have it here locally, it's actually letting us see the actual value. And then it has all the other outputs as well. So now that we did that, we're going to do the React front end. Okay, I'm going to say this, because of time, we're going to have to do it how it is, which is copy and paste. But I know that this class isn't so experienced with the front end, and as someone who's worked heavily with front end, how we're going to do this breaks my heart, because this doesn't simulate how you're really going to create a front end. One, not in the sense of how basic it is, which of course it is, it's a lab, but importantly, in how we're getting the code into the file. I'll show you guys what I mean right now. But what we're going to do first is go into the correct folder, because we have our Terraform folder, and then we also have our front end folder. So we want to be in the front end folder. Within this folder, what we're doing is whenever you're like, you have to establish, in our case, we're using Vite. And if some of you are saying, wait, I thought we were using React. React, yeah, we are using React. React has different frameworks that you can use. So you can use like Vite, you can use next.js. In our case, we're using Vite. We're not going to use roll down, because as it says here, it's experimental. And then we are going to install with npm, and we are going to start it now. So here's the thing though, it's going to install, this should have no problems for us. If you're ever creating a React app, don't use the create React app like flag. Either utilize Vite or Next.js. And the way that I decipher for myself is, if you're making a website that has, or a web app or website that utilizes SEO, which is search engine optimization, use Next.js, because it's optimized for search engines. If you do it right, you can really get that score high. On the other side, there's Vite, which is really good if you don't need SEO, which is like if you have internal products and stuff like that, like internal tools you're making, because it's going to be like cleaner and faster. It should be. But with Next.js, there's ways to make it blazing fast as well. But they are two different. They're two different paths. Okay, so here's the thing. Right
Are you
now
saying, excuse me, are you saying, you're not saying node.js, you're saying next? Or
correct.
Nest?
Next.js.
Next.
Correct.
Okay.
So yeah, Node.js, if I utilize it, it's more for backend. If I'm using JavaScript on the backend, I'll use Node.js. All right,
Okay,
so
thank you.
Actually, any other questions before we jump into this? But also, we are limited on time. All right. So here, since this is running, right now we have like a running front end. I'm going to go ahead and open this here. Whenever you create a Vite app to start, this is what you get. This is already built in here. You have a little counter. It shows you, oh, functions work. But this is it. This is actually just a static site. It's not doing anything. But we do know it's running locally. Here in our terminal, this is running the server. So if we kill this, that's it. So I'm going to add a new thing here. And I'm actually going to rename the first one to front end server. That way I don't accidentally close it while we're working. And then on this other instance of the terminal, now we're back in the front end. So if we need to do any commands, we can just do it within here. So let me close this one thing real quick, and let me find where this. Okay, cool. So whenever you're creating a project, a front end, you want to install, because there's going to be some sort of, let's close this here. even though like we haven't added any new libraries, here in the package JSON, there's already libraries that just come with Vite or with Next.js or whatever you're using. So you have to install them. If not, it's just nothing's going to work. And then here, what we're going to do is install a new library, which is the stuff that we need for DynamoDB. And then here you should see them populate. It should be in here. Oh, there you go. Okay, cool. So now that we got that, that's like the absolute basics. What we're going to do is here in the source folder, and it has to be in the source. It's not optional. We're going to create this. So you guys saw the touch before, but if you guys wanted to use the GUI, you can do that as well. We made AWS config. There's not a lot of config that has to be done for this project because it's so small, but we are specifying our region again. We are specifying these credentials, and we are naming the table. And if you guys remember here in our output, we have our access key, and then we have our secret key. Cool. That's essentially it for the config. We're not going to have to do that ever again. Hold on, I lost my place in these steps. Actually, why does it want us to do this? Oh, okay. So here what we're doing is, in this output, should we see it now? No, actually we should. Okay, I don't know, the step said to, oh, I see. That's weird. I think we did this step out of order because it's just telling us to do this portion again. All right. Here's what we're going to do that's actually the right next step. We're going to add another file. This one's going to be called dynamodb.js. If you're not familiar with the front end or the patterns of files, JS is JavaScript. JSX is a JavaScript. Oh, I forget what it's called. All right, well, that is what it is. Okay. In this DynamoDB.js here, so far what we're doing is we're importing. And when I said this isn't how we code, this is what I mean. There's never going to be any time in history that you're just like kind of what this reminds me of is like a printer, right? When you print something from, a printer, it's printing it line by line by line. That's not how humans code, right? Normally we're just importing one thing at a time, and then we're creating basic function names and adding things as we go on. But in this case, we're just kind of throwing it at you top to bottom. So here we're importing from the library. If you guys remember, we had installed those DynamoDB libraries. So here we're getting the actual client from it. We're also getting all this stuff that we're going to need to interact with it, right? Like to put, to scan, which is C, delete, to update. And as we're going through this, here we have this client here. Actually, let's see. Yeah, it's just the client, the region, the credentials. This is actually pulling in from our config. If you guys remember, we had configured this. And then here here it's just breaking it down. So within this config, it's saying we want the region for the region. Within the credentials, we want the credentials, which once again are right here. Or no, I'm sorry. Region and the credentials. And here we're just pulling it in. I'm not sure if you guys have seen this before, because this right now is either going to blow your mind or you're going to be like, yeah, dude, keep moving. So what's the skill level of the class? Well, all right, question. Has anyone seen imports before?
I have.
I mean, just
I know
Python
this.
import.
Say again?
No, import with JavaScript, import resolution, module resolution. I know there's two. I know it's a really big issue because there's two ways of doing it, especially with JavaScript. You use import or what was the other one again? Yeesh.
So, well, essentially the TLDR for the scope of the class at least, whenever you're importing, you're either importing from a library or you're importing from a file. If we ever get to where we use reusable components, you're going to be importing everything. It's like the lifeblood of how all this works. So here we're just creating something called a client. We're utilizing a function that's coming from this library. And what the function needs is they need parameters. It needs region, it needs credentials. And we're pulling that from our own import from this AWS config. This is one of those things, as you're doing it on your own, definitely play with it and kind of like experiment. So within here, this is just saying, hey, let's get the actual document from DynamoDB. This is also a built-in function from this library, and we're passing it in the client. That's why we created this object. That's called client. What else we're going to need to create within the same DynamoDB is we're going to export something here. Export is the same way we're importing here. You can import exports, right? You have to export them or you can't import them. So here, that's telling us that this task service is going to be utilized on another file. So we're creating a function. We know it's a function because of these brackets. We're creating a function called task service. This is using async await. Right now, it's utilizing getAll function. What async await means, it's formally, it's a promise. What that's saying is when we run this function that's called task service, it has a variable that we're defining that's called response. But this response is promising us this. It's promising us something. It has to get it from somewhere else. And what this async await means is that the response variable is not going to have, have a meaning, if you would. It won't have a value until it actually gets it from the backend. That's the, or either the backend, the other file. It's usually a backend if we're waiting for it. Yeah, so essentially that's what it is. The response is going to await this before it says, hey, I am a usable response. Hopefully that makes sense. What this does is it stops race conditions. Because, for example, let's say I tried, this won't actually do anything because the code's incomplete. But let's say that here we tried to console log, actually within here. Say we tried to console log response. Jesus. Sorry, guys, this is here. So yeah, say we tried to console log a response, but the response doesn't exist. It's just going to be null. So if we're utilizing that in our code for something detrimental, it would create errors. But since it's awaiting, that means the console log or the conditional, wherever we're utilizing it, it's not going to be used until the promise is fulfilled. All right, and then for time, that's the most we can elaborate on that. Within this, not only do we want to get all of the task, right? Because remember, task service is what we're defining. But some of these functions that we're utilizing, it's getAll, create. GetAll is going to just get all the tasks. Create's going to allow us to create a task. If we want to delete a task, we're going to create a delete one. And then you'll notice within these that, for example, like I said, there's put, post. Whenever you create something, you're going to use put. Whenever you go to delete something, you're going to use this delete command here. Yeah, yeah, we won't go into the weeds too much. Okay. So then here's another thing we're doing. Remember, this is for our task creator. We want to be able to toggle if it's complete or not. And then here we're going to do this once again. We're utilizing the same function that we've defined up top. And here we're going to update, right? So here we're going to pass it in, which I guess we could have talked about in here. Each of these functions to work, whether it's a put, a delete, whatever, it has to know where the function's landing, if you would. So for example, the put command specifically needs to go to a specific table. Because if we're creating a task, we want to put that task within a specific table. So here it's AWS config / table name. And if we click on table name here, remember, we defined table name already in our config file. So the config file is like the source of truth. And then this file is just pulling in what we need. So this is this takes away from like hard coding in values, especially if we want to keep them secret from the user. So once it gets to the specific table, the item already has a name called task. That's what it's going to create as a task. Same thing when we go to delete it. It has to go to a specific table. And it's going to find this now with the key. Because once something's created, everything has an ID. And that's how we refer to it once an ID is established. The create is, in turn, establishing that ID. Then we have toggle complete. This is saying, hey, we just want to update this command. Okay, cool. It has to know which table to go to. Then it's going to use the key. But instead of deleting it, like this function, this is updating the command. So here it's going to update the expression set complete equals completed. But here the expression attribute value is completed. So it's saying, cool, like this is complete. I know this is kind of going a little quick, but once we see it come together, you can look back through this code and then it definitely make way more sense. So this is essentially the DynamoDB. Remember, this is just the database interactions, right? So we can get, create, delete this. All right, cool. So now we kind of got to go to like the actual money here. In an app, whenever you go, you're going to see main.jsx, in case you guys haven't interacted with this. And it always looks like this. So essentially, this is your starting point for the app. And what it's going to do is, this is the parent component, and the first child component is the app itself, so app.jsx. So if we go into app.jsx here in the files, this is the money. Because if you guys remember this, here, this localhost, we have the logos, the highlighting functions, whatever. All of this is coming from here. Like even just to show you, like, where's this header? You see I put all those random letters, and then, oh, what the hell? Oh, I accidentally have some. And in here we have all those random letters, because this is literally what it's doing. It's rendering the app.jsx. And then what you would do is the same way that you have this main that has a child, that's the app. Within the app, that's where all your components are going to live as the child of that. Not super important for today, because we're not making child components, but just like a heads up, because when we get into more app stuff, at least that way you're just ahead of the curve. What I'm going to do here, and once again, this is not how you code. This is for brevity. We're going to just throw in some stuff how a printer would, not how a human would actually code this. So ignore the errors and ignore the light blue stuff, because we're just building it. But here's the same thing we did before. We need to import stuff. So what we're importing is useState and useEffect from React. The task service from DynamoDB, that's from the actual database. And then here we're getting the user ID from the library that's already built in, UID. We also have a styling file. Here there's something called app.css. This is like where your styling comes from. So there's different ways to do it, and I think this is a little bit more dated for most stuff, but that's out of the scope of this class. And essentially any sort of styling we're going to use in here. We'll show you that, but it's also imported, because remember, you import external libraries and internal files. So the first thing you would do is create a function. And one of the things that I was kind of saying is like for example, the function's not even closed. Normally you got to close the function, right? So the function is called app. It has the brackets, it's a function. These consts, this is like really cool. These are called React hooks. And what they're utilized for is state, it's a sense of state management. So what we're doing is we're creating variables. For example, task, new task. Does that say loading? Yes. And then error. It's hard to read with the squiggles. This is where the variables are defined. So we don't have to define them anywhere else. They're defined here, but we're utilizing useState. Within this useState, this is the definition. So right now, what is a task? It's an empty array. Okay, right now, what is a new task? It's a blank string, so on and so forth. Set task, what that's going to do is update task. Then here you have set new task. It's going to update new task, which means going forward, you're never going to redefine these variables because they're defined. You only define them once, but you're going to use set task to update them. And then we'll show you guys that as we get to it. We're kind of low on time. I wonder how much, okay, is this pace too slow for you guys? Like, is this a little like, is this too basic? You guys want me to like kind of speed ahead, or is this what you guys need?
I'm
I mean,
good with the pace.
I think it's okay. Like, I don't know what, I think it's more like when we get into it and start clicking buttons and
Okay.
actively
So
doing
that
it.
sounds
It'll
like
be,
at a minimum, it sounds like you're not yet familiar with like once again like imports or React hooks and stuff like that, correct? George, you're
I
saying
mean, in
something, but
this, good.
I think your face said it, but but you were muted.
Yeah, I'm not familiar with anything, so
All right. Okay, cool. Because yeah, we're probably gonna run over time a bit, but I mean, if we're just throwing this at you, I don't see how that's super helpful, you know? Okay, so next we have something called a use effect. This is also part of the React library. So you've seen use states, use effect. Use effect is pretty cool. Essentially what it is like when the React app loads, it's going to ensure whatever happens in here only happens once initially. Uh, in here, there's something called a dependency array. It's right here at the end. This is the proper format. If you have a blank dependency array, it only runs one time on load. If we got rid of this, this function would run indefinitely. So you never would do that ever. I don't even know why that's an option. But what you can do is in the future, you can put stuff in here and only have this update when something specifically triggers it. For now, we just need this to load once because of our app is so simple. But within this use effect, we're creating a function called load task that's going to actually get the task from the backend if they exist. If you guys remember, there's a sync await. So within here, we're going to try something if you would, right? This is called try catch. Finally, it's part of one syntax. With this try, we're defining fetch task. So we're going to name this, or what we want this to be is the get all. If you guys remember, this should pull up. Well, it's within task service, yeah, so we don't have to. Okay, if you guys remember here in the database, we define get all, which is going to get everything from the backend. So the fetch task are going to be the all tasks that we're getting. This await is going to make sure that this fetch task is not defined until the data actually exists. Once that happens, once the promise is fulfilled, there's set task. And here what that's going to do is we're going to define, because if you remember, task is currently a empty array. But when we set the task, we're setting it to this variable, which is the promise. So this array is going to be populated, you know, with like task 1, task 2, but of course not really whatever they're named. And it's not going to physically update that. It's just to kind of give you a point of reference because everything's saved in the state, which means you don't have eyes on it, at least not at this level. If this, let's say the promise, like, because it has to wait to define it. Let's say instead of getting the task, it gets an error. That's where this catch comes in. We have something called error. It's going to actually set it failed to load data. And then finally, regardless if the try works or the catch, we're going to set the loading to false. Because here in our use case, we set loading to true, which means that when the page starts, we're going to be loading. We're going to stop the loading once we get that data. All right, we'll try to speed up a little bit here if we can. Okay, so aside from that function that we created, I'm going to close this here, that use effect, just to make everything else more readable. So here we're creating another function. This function is called add task. The use effect and the get task was to literally load tasks to get all the tasks. Now what we want to do is add a new task. So here, if there's no new task, trim it and return. Okay, I guess that's just a failsafe. All right, within this, we're defining task, which is not the same as this, just to be clear. This task only lives within this function. So this is essentially kind of like how schemas work, where you have a value and attributes that only currently exist within this add task function. So the reason we're doing that is because what we're going to do here is we're going to try and await the create to actually create a task, right? And then if that works, then we're going to set the task right here. And this can set multiple tasks at once because it's a spread operator. You guys don't need to know that yet. And then what'll happen is we can set a new task. here it would be the string. So this is essentially like, actually, is this correct? It seems a little odd. Set task to the spread operator. Oh, I see, because that's set new task, correct. Oh yeah, here we go. I got tripped up with the naming convention because I didn't create this lab. So yeah, with the set task here, that's what it's going to do. It's going to update this array if it works. And then set new task is going to be blank because the new task I think is used as like a placeholder. If there's an error, we're going to set the error. And then where are we at here? Create. Oh, and then also just once again, the same thing too. If you guys remember, create is what we had defined here in our DynamoDB file. And then I think you guys should be catching the pattern right now where essentially here we're utilizing all of the functions that we created within the database itself. Let's see this. Okay. So now what we're going to do is create a, am I tripping? Oh, it's just, oh, I see, it doesn't close all the way. Okay, so here we have another try catch, right? Whenever we're utilizing endpoints, you do want to use this try catch. In this case though, toggle task, yeah, it's just kind of weird here. All right, we're creating a function called toggle task. In here, we're creating a task, which once again is not this same task. This task is like the one that's being stored and called. This one, you can think of it as a temporary task that's going to be used to create the actual task, if that makes sense. So the naming conventions could be updated. We could talk about that if we have time at the end. So with this task, what it's going to do now, because we're toggling it, first thing, how can it toggle something that it doesn't know what it is, right? So it's going to find it. Here it's actually mapping through it. Actually, no, I'm sorry, it's not. It's what are we doing? We're creating a function. And then here it's essentially doing a check. So this should return a Boolean. Because here it's saying, is the task ID equal to the ID itself? And then here for the task, let's see here. Actually, oh, it is mapping. I apologize. Oh, because of the find function. All right, I got tripped up. So yeah, here with the find function, it's actually iterating, because you could say mapping, but it's iterating through and checking once it finds the ID, the task ID that matches the backend ID. So once it does, then it's saying, hey, I found it. And then that's going to be returned here. And then now it can actually map through it. So essentially here, what it's going to do is when you go to toggle it, which we already remember we had defined. Actually, where is this one defined at? Oh yeah, okay, just in work. We defined in DynamoDB. Once we have that, remember it's awaited, so there's a promise, then we get to set those tasks, which at this point should be toggled. So one more for you here. I'm getting a little tripped up with this just because it's not a real format. Like I said, nobody codes like this. You know, usually you create the function as a whole and then create, you know, there's a process. But anyway, here, then there's delete task. Same thing. We're naming this whatever we want, delete task. We're doing our try catch. Within here, we're waiting for the service to finish delete by the ID. Once it deletes here, it's setting task, which is the task filter, which should filter. That's actually interesting. I wonder what this is going to set it to in this instance. Oh, actually, it's just going to update the task to remove the current one that we've set for deletion. Okay. So then here we do have this finally, which normally we'd create first, which once again, which is why this is really weird. So here we have a variable. It looks like it's freestanding, but it's not. So it says if loading return, and it's just going to be a loading screen. So if we don't have that data back yet, if remember up here we had defined loading starts out as true, we turn it to false once we get all the task. Essentially what this would do is it's just going to return the loading only. But if it's not loading, then it's going to return the rest. Essentially, whenever you create a function on the front end, right, the main function here for this app component, essentially what it is, all of this beginning stuff is functions. It's variable names, it's functions, it's hooks, it's whatever you need to actually like code, if you would, like to make the magic happen. But then right here in the return, this is everything the user sees. So the return's important. You should never do any sort of functions, and I'll check this one, see if it's correct. But you shouldn't do any functions within the return. All your functions should be done above it and then just called within it. Because remember, this is just what we're displaying. So here you usually create a div, which has a closing div. That's how you normally would code. You open and close it. And then in here, we're using H1 to create a title. Then we're giving it a class name. Everything has a class name because we're using CSS. This is where the stylings come from. So here we have a class name container. Here we have a class name called subtitle. If we go into the CSS, we should see these guys. Oh no, we have to create it. That's right. And once again, this, like I said, I'm doing you a disservice. This isn't how you code. Normally, we're going to create the div. We're going to give it a class name. Then within a style sheet, we're going to go and create that comparable style. And then once again, class name for this. Okay, cool. We'll go into the style sheet, add the styles for that. But in this case, we're just kind of throwing this code at you, and it's just not a human format. All right, let's see what else we got here. Yeah, so right now it's just this, literally just this name that. Here we're handling errors. Well, not truly. Well, it's just saying if there is an error, if an error is true, then display this, which is an error message. Aside from that, we have a form that we're utilizing. I think we're going to start blowing through this because this is taking way longer. And once again, I just don't feel like, this format's the best format to really learn front end if that's the intention of this. Because it's obviously not a full front end, the S3 stuff's the most important stuff. So actually, here's what I'm going to do for you guys. Let's kind of speed through this. Let me see on my other screen if I can pull in. Here's what I'm going to do. I'm going to pull in the other version I was working on just to make sure that this page is set up right. Because like I said, at this point, we do got to move ahead. And if we have time at the end, I can actually answer your questions and I'll help you guys during the assessment as well, or during your challenge. What's this called? Terraform. All right, give me one moment. I'm just pulling up my old file here. Okay, so through the power of magic, what is this, the app.jsx? Of course it is. I'm just gonna go ahead and post in the version that I had. And like I said, we could talk about whatever specifics we need to. We do have an index.css, which I know I updated because of one line. And then I think we have app.css, which we do. Oh, yep, right here. I'm going to update this as well. Okay, so yeah, I'll give you guys more of a breakdown if there's time at the end, because this shouldn't be like the main focus of the class. It's way too much information. All right, so let me just take a look at the, all right. Okay, the one thing we can do right now is check our localhost. Bam, magic. I know you guys are like, what the hell, how'd you do that? It's all there in the code. I'll show you guys that, like I said, if there's time, we can really break it down, or if you guys want to stay after, I'll break it down for you. But here we have an app, it's called Task Manager. If I want to enter a task, let's say I want to do 10 push-ups. I hit enter, you can hit add task, I just hit enter. I misspelled it, but that's fine because we can delete it. Bam, look at that, right? Let's say we want to do 10 sit-ups and then 10 push-ups. And then here, let's say we toggle this. It's checked. Here's what we're going to do right now. That's created through the power of magic. What we're going to do right now is actually deploy this to S3, because if you remember, this is local. It doesn't exist outside of my computer. Am I in the wrong? Oh yeah, I'm in the wrong. What the hell? What is this saying? Just one moment. Let me see. The user provided path test does not exist.
Is
Oh,
the
we
S3
never.
bucket?
Oh, I'm sorry.
Yeah, is the S3 bucket created? Did we apply?
It's a good guess, but here specifically, this dist, which is a folder, doesn't exist, and it doesn't exist because we have to run npm run build,
Ah, okay.
and then now that directory exists. So now we can go through, and now we can actually push it. All right, cool beans. So, and then set correct content type. Okay. Yeah, for time-wise, I'm gonna just start banging this out, which isn't the best, but we're kind of way past the schedule here. What we're doing now is we're setting the content types here, which is we're taking the HTML, and then we're also taking the JavaScript. And then it's just like part of the process to actually push it, right? So essentially, once we build and get the dist, it's two main commands, one to deploy and then one to set to correct content types. And then here we can test our app, which you're like, what the hell? This is magic. Right here, that's it. Remember I said there was just those two main steps once we build, which means if we go to this site now, we should see our site live. Okay, you can see the site, but you'll notice here, I don't know if it's my dark reader. Wait, okay, the CSS isn't applied properly, at least maybe the coloring isn't, but with dark mode you can see it. So that's obviously not what we'd want, but we're just copying what was available. We can fix that later. But what's important here is that you see that this is an actual URL. Like right now, if you guys want, I could send you the link and you can all go there. So let me see what else we can do here. So that was just to get the output of the URL. We did that. Now we did it. Once again, here we can, actually, did you guys notice that? Within the task manager, I had already marked that one as complete. Within the live version, it's already marked complete. That's because it's literally pulling from the same exact database. It's the same exact app, just one's local, one's deployed. Let's see what else we can do here. If we want to verify the information, we do have a line for that as well. And remember, no one's ever going to remember all of these lines, so just make sure you have your resources with you in your notes. But essentially here, it's scanning the database. Specifically, then it's like, hey, we're going to the table name, task manager, task. If you guys remember, we named that ourselves. And then the region, you have to specify US East once. And when we pull it, what you're going to notice here is the database. This is the database information. So it's showing us the items. Remember, we created that object. Here, the title is 10 sit-ups. 10 sit-ups, is it completed? It's false. And we can even verify that here. And then let's say we wanted to click on this one. All right. And then let's say we leave here and we re-pull that in. Now, 10 sit-ups completed is true because this is the actual live database. Let's see what other fun stuff we can show you real quick. Here it says if you want to understand what you built. All right, we're going to run this here. What we're doing is we're going into the Terraform folder because right now we're in the front end. Remember, we want to be in Terraform. And then we're typing in Terraform state list. This will give us the list of states. This is everything that we just created. We created the table task, the front end key. You guys will remember this. We went through this whole process. And then that's just like, I guess you can use as a verification, or if you don't know what's on there, if it was someone else who made it. Let's see what else we can do for you. If you want to see the configs for it, you can see that as well. And then here it's not many, but we have the index document. We know it goes to HTML. Remember the error document, HTML. So this is all the stuff that we configured earlier, but now we can actually see it here. In addition to that, we can check the table status, which we know is cool. Oh, what the hell? We got to specify a table or a region. Let's do this right here. We're going to do US1. Active. But of course, we know that because we can play with it. After this, the next thing to do is to clean up